This video is about trigonometric inequalities. This is AP Precalculus, topic 3.10. If you appreciate the content, please give it a like. The graph of f is defined on the interval from negative 2 pi to positive 2 pi as shown. What are all values of x for which f of x is less than or equal to 0? F will be less than or equal to 0 where it is below or on the x-axis. So that's on the interval from negative pi to 0, including negative pi and 0, because we want to know where f of x is less than or equal to 0, so we should include these two endpoints where f of x is equal to 0. We will show that the endpoints are included by using a bracket on our interval notation. So the first interval is from negative pi to 0, union, and then our second interval is from pi to 2 pi. These intervals can also be represented using inequalities like this. On a free response question, you can use either interval notation or inequalities, but a lot of your AP exam will be multiple choice questions, so be able to recognize the answer in either form. If you have not yet memorized the 9 trig values on this chart, pause the video and memorize the chart right now. Example 2. What are all values of theta on the interval from 0 to 2 pi for which the sine of theta is greater than or equal to radical 2 over 2? Since sine is the vertical displacement from the horizontal axis, we are looking for all possible angle measures where the y-coordinate is at least radical 2 over 2. We can find the reference angle by asking ourselves the sine of what angle is equal to radical 2 over 2. We have memorized that the sine of pi over 4 is radical 2 over 2. So pi over 4 is the reference angle. The reference angle is the angle between the terminal side and the x-axis. On the interval from 0 to 2 pi, here are the 4 angles with a reference angle of pi over 4. Eventually, we need to find where sine theta is greater than or equal to radical 2 over 2. But first, we find where sine theta is equal to positive radical 2 over 2. So, since we want sine theta to be positive radical 2 over 2, we will disregard any solutions in the third or fourth quadrants. We will stick to the first and second quadrant, where the y value and thus the sine function will be positive. The angle in the first quadrant with a reference angle of pi over 4 is pi over 4 itself. We can think of pi as 4 pi over 4. So this angle in the second quadrant is 3 pi over 4. These are the two angles at which the y value, or vertical displacement, is radical 2 over 2. This horizontal blue line represents a y value of radical 2 over 2. We are looking for the intervals where the y value, and thus the sine function, is greater than or equal to radical 2 over 2. Right here, the y value is radical 2 over 2. As we continue to rotate around the unit circle, you can see that the y value is now greater than radical 2 over 2. The y value will continue to be greater than radical 2 over 2 as I rotate through this interval until I get to this position, where the vertical displacement is back to exactly radical 2 over 2. If I go any further than that, the y value falls below radical 2 over 2. So the solution to the inequality will be the interval from pi over 4 to 3 pi over 4, because this is the interval on which the angles land at a vertical displacement over radical 2 over 2. You can either express the solution to this inequality as an inequality, where theta can be any angle on the closed interval between pi over 4 and 3 pi over 4. Or you can express your solution using interval notation like this. Because we wanted the values of theta that would cause sine theta to be greater than or equal to radical 2 over 2, we will use brackets instead of parentheses to show that the pi over 4 and 3 pi over 4 are included in the solution. Example 3. Let f of x equal 4 plus 2 cosine x, and let g of x equal 3. What are all values of x in the xy plane between 0 and 2 pi for which f of x is less than g of x? So we are looking for where 4 plus 2 cosine x is less than 3. Let's start by isolating cosine x algebraically. Subtracting 4 from both sides gives us 2 cosine x is less than negative 1. Dividing both sides by 2 gives us cosine x is less than negative 1/2. We can find the reference angle by ignoring the negative sign and asking the cosine of what angle is 1/2. We have memorized that the cosine of pi over 3 is 1/2, so pi over 3 is the reference angle. On the interval from 0 to 2 pi, here are the 4 angles with a reference angle of pi over 3. Eventually, we want to find the angles where cosine is less than negative 1/2. But let's begin by thinking about where cosine is equal to negative 1/2. Since we want cosine to equal negative 1/2, we will stick to the second quadrant and the third quadrant, where the x value, and thus the cosine, will be negative. At the intersection point of both of these angles, the horizontal displacement, the x value, is exactly negative 1/2. Looking at the reference angle, we can think of pi as 3 pi over 3. That makes this angle in the second quadrant 2 pi over 3. And it makes this angle in the third quadrant 4 pi over 3. I'm going to begin to rotate starting from 0 radians. Notice that the horizontal displacement, the x value, is greater than 1/2 as I rotate, until I rotate to this first angle. Right here, the horizontal displacement is exactly negative 1/2. As I pass this angle and go into this interval, the horizontal displacement is now less than negative 1/2. And the x value will continue to be less than negative 1/2 until I get to this other reference angle. So the solutions will be the interval from 2 pi over 3 to 4 pi over 3, because these are the angles where the horizontal displacement is less than negative 1/2. You can write your solution as an inequality like this, or using interval notation like this. Notice that this time we are using parentheses instead of brackets to show that the endpoints are not included. We want the values of x that will cause cosine, the horizontal displacement, to be less than negative 1/2, not equal to negative 1/2. The horizontal displacement is equal to negative 1/2 at these endpoints, so they should not be included, thus parentheses. Example 4. Let h of x equal 3 cosine x, and let k of x equal radical 3 plus cosine x. What are all values of x in the xy plane on the interval from 0 to 2 pi, for which h of x is greater than k of x? So we are looking for where 3 cosine x is greater than radical 3 plus cosine x. I notice that we have like terms on opposite sides of this inequality. So let's pull these together by subtracting cosine x from both sides. 3 cosine x minus 1 cosine x is 2 cosine x. So we have 2 cosine x is greater than radical 3. Next, we can isolate the cosine x by dividing both sides by 2. That will give us cosine x is greater than radical 3 over 2. Before we get to where cosine x is greater than radical 3 over 2, we need to start by thinking about where cosine x is equal to radical 3 over 2. We can find the reference angle by asking the cosine of what is radical 3 over 2. We have memorized that the cosine of pi over 6 is radical 3 over 2, so pi over 6 is the reference angle. On the interval from 0 to 2 pi, here are the 4 angles with a reference angle of pi over 6. Since we want to know where cosine is equal to positive radical 3 over 2, we will focus on only the first quadrant and the fourth quadrant, where the x value, and thus the cosine, is positive. The angle in the first quadrant with a reference angle of pi over 6 is pi over 6 itself. We can think of 2 pi as 12 pi over 6. So this angle in the fourth quadrant is 11 pi over 6. At pi over 6 and at 11 pi over 6, the horizontal displacement is exactly radical 3 over 2. By the way, I'm going to call this horizontal displacement instead of calling it the x value to avoid confusing it with this x, which is now acting as the angle. So the horizontal displacement is radical 3 over 2 right here. We are looking for where the horizontal displacement is greater than radical 3 over 2. Let's start at 0 radians. Notice that at 0 radians, the horizontal displacement is greater than radical 3 over 2. It's further to the right. The horizontal displacement will continue to be greater than radical 3 over 2 until we get to pi over 6. Again, at pi over 6, the horizontal displacement is exactly radical 3 over 2. We just identified part of the solution set, one interval where the horizontal displacement is greater than radical 3 over 2 is from 0 to pi over 6. I'm putting a bracket on the 0 to show that 0 is included in the solution set. At 0, the horizontal displacement is greater than radical 3 over 2. I'm putting a parenthesis on the pi over 6 to show that pi over 6 itself is not a solution. At pi over 6, the horizontal displacement is exactly radical 3 over 2. It is not greater than radical 3 over 2, which is what we want. As we continue to rotate clockwise around the unit circle, the horizontal displacement is less than radical 3 over 2 for this part of the journey. The endpoint is to the left of the blue line. All right, we are less than radical 3 over 2 until we get all the way around and back to this position. At 11 pi over 6, the horizontal displacement is again exactly radical 3 over 2. As we continue past 11 pi over 6, the horizontal displacement is again greater than radical 3 over 2. So we've identified another interval of solutions from 11 pi over 6 to 2 pi. Be sure to use a parenthesis on the 11 pi over 6 to show that this is not a solution to this inequality. At 11 pi over 6, the horizontal displacement is exactly radical 3 over 2, but it is not greater than radical 3 over 2 like we want. We will put a bracket on the 2 pi to show that at 2 pi, the horizontal displacement is greater than radical 3 over 2. So 2 pi is a solution and will be included with the bracket. You can also record your solution intervals using inequalities like this. Notice that wherever we would use a bracket to show that the end values are included, we will use an or equal to sign. Like this less than or equal to sign here and here shows that the 0 and the 2 pi are included as part of the solution. Wherever we would use a parenthesis to show that a value is not to be included, we will stick to a less than sign without the or equal to. Let me mention a couple of common mistakes I want you to avoid. Many students will notice that the solutions are on this part of the unit circle right here. So it's tempting to try to write one inequality that includes this part of the unit circle. So by mistake, sometimes students will do something like this and say the interval from 11 pi over 6 to pi over 6. But this does not make sense because 11 pi over 6 is bigger than pi over 6. So we would never say that. So to fix that, some students try to reverse this. They say, fine, I'll reverse the order and write pi over 6 to 11 pi over 6. Doesn't that mean this same interval? Well, no, it doesn't. Because pi over 6 means that we're starting from here and then rotating all the way around to 11 pi over 6. So we're actually now describing this interval. And this is the interval where the horizontal displacement is less than radical 3 over 2, not greater than. So this would be exactly the wrong answer. So you have to do it this way. 0 to pi over 6, rotate around, and then 11 pi over 6 to 2 pi. For example 5, I'm going to show you how to solve a trigonometric inequality using a sign chart. First, make sure you have 0 on one side and call the other side f. In this case, f at theta. We need to begin by finding where f at theta is equal to 0. As I write f of theta down, I'm going to go ahead and factor it. I notice that both terms have sine theta, so let's factor out the common factor of sine theta. Dividing the first term by sine theta, we see that 2 times sine theta will be left behind. Dividing sine theta by sine theta gives 1. So we factored it. We can solve this equation by setting each factor equal to 0. So we're going to have sine theta is equal to 0. And we're going to have 2 sine theta plus 1 equals 0. I'm going to do this algebra in my head, subtracting 1 and dividing by 2. So we would get sine theta is equal to negative 1/2. Let's start by finding the angles where sine theta is equal to 0. Sine is the y value on the unit circle, and y values are equal to 0 right here, and also right here. That's at 0 radians and pi radians. So theta equals 0, or theta is equal to pi. Those are the two solutions from sine theta equals 0. How about sine theta equals negative 1/2? We can find the reference angle by ignoring the negative sign and asking ourselves the sine of what is equal to 1/2. We have memorized that the sine of pi over 6 is 1/2, so pi over 6 is the reference angle. On the interval from 0 to 2 pi, here are the 4 angles with a reference angle of pi over 6. Since we want sine theta to equal negative 1/2, we will stick to quadrants 3 and 4, where the y value, and thus the sine function, is negative. We can think of pi as 6 pi over 6. So this angle in the third quadrant is 7 pi over 6. So that's another solution. Theta equals 7 pi over 6. We can think of 2 pi as 12 pi over 6. So this angle in the fourth quadrant is 11 pi over 6. That is a fourth solution. Theta equals 11 pi over 6. Now it's time to make the sign chart. We're going to need a row for each factor of f of x. So I'm going to need 2 rows. We are going to put a vertical line at the beginning and end of the limited domain. So we are restricted to the interval from 0 to 2 pi. So we need to label the beginning as 0 and the very end as 2 pi. between 0 and 2 pi, we will put a vertical line at each of these 4 critical values. Well, I see that one of them is 0. So I will have 3 vertical lines at the other 3 critical values where f of x is equal to 0. Your critical values must be written in order from least to greatest. This is a number line. Label the sign chart as being f of theta and label each row. So we have one row for sine theta and we have a second row for 2 sine theta plus 1. On the sine theta row, mark the locations where sine theta is equal to 0. Remember, sine theta was equal to 0 at 0 and pi. So I'm going to put a blue line at 0 and pi. These are important because these are the only places where sine theta might change signs. Now, how about the 2 sine theta plus 1 row? That factor led to the equation sine theta equals negative 1/2, which had the two solutions 7 pi over 6 and 11 pi over 6. So on this row, I'm going to highlight 7 pi over 6 and 11 pi over 6. These are the only two places where this factor might change signs. So we need to go back and decide whether sine theta is positive or negative in each interval. I don't actually need to check all 4 intervals. I really just need to check this interval between 0 and pi, and then the second interval from pi to 2 pi. That's why I marked these blue lines, because that shows us the intervals that we need to check. There will be no sign change between pi and 2 pi, so I can check any interval. Between 0 and pi, which is from here to here, we could use a test value of pi over 2. At pi over 2, sine, the y value, is positive. So on this interval, sine is positive. Between pi and 2 pi, sine is negative. The y value is below the x-axis. So sine is going to be negative in all 3 of these intervals. Now it's time to decide if 2 sine theta plus 1 is positive or negative in each interval. These 2 blue lines are here to remind us that we only have to check 3 intervals, not 4. We need to check the interval from 0 to 7 pi over 6, the interval between 7 pi over 6 and 11 pi over 6, and the interval from 11 pi over 6 to 2 pi. We can use pi or 0 as test values. Even though 0 is on the end point of this interval, we are still allowed to use it as long as it wasn't one of the critical values where this factor was equal to 0. But let's go ahead and use pi. If we plug pi in for sine theta, the sine of pi is 0. The y value is 0 at pi. So we get 0 for this term, and we're left with plus 1. So this factor is positive in this interval. What would be a good test value to use on this interval? Between 7 pi over 6 and 11 pi over 6 falls 3 pi over 2. So let's evaluate 2 times the sine of 3 pi over 2 plus 1. The y value, and thus the sine at 3 pi over 2, is negative 1. So this is going to be 2 times negative 1 plus 1. This is negative 2 plus 1, which is equal to negative 1. What matters is that this factor is negative on this interval. For the final interval between 11 pi over 6 and 2 pi, we are allowed to use 2 pi itself, even though it's the end of this interval. If we plug in 2 pi right here, the sine of 2 pi is 0. So 2 times 0 is 0, plus 1 is positive 1. What about the overall sign of f of theta? We're basically counting the negative signs. This first interval has no negative signs, so f of theta is positive. An odd number of negative signs means the overall sign will be negative. An even number of negatives on this interval indicates that the overall sign is positive, and the last interval has only one negative, so the overall sign is negative. Remember, we are looking for the values of theta that will cause f of theta to be less than 0. So the solutions will be in these intervals where f of theta is negative. I like to record the solution on the number line before writing the final answer. The values of theta that satisfy this inequality fall on the interval from pi to 7 pi over 6, union 11 pi over 6 to 2 pi. Notice that we are using parentheses to show that these endpoints are not included because the endpoints are where the f of theta is equal to 0, but we only want where f of theta is less than 0, not equal to 0. If this had been a less than or equal to problem, we would have used brackets on these endpoints instead of parentheses. You can also record your solution as an inequality like this. Example 6. What are all values of theta on the interval from 0 to 2 pi for which 2 cosine squared theta plus cosine theta minus 1 is greater than or equal to 0? Let's begin by labeling this part of the inequality as f of theta for easy reference. To make our sign chart, we will need the values of theta that will cause f of theta to equal 0. As I copy down f of theta, I'm going to go ahead and write it in factored form and set it equal to 0. I like to start with the first term. 2 cosine squared theta can only factor as 2 cosine theta times cosine theta. Next, I skip to the third term. Ignoring the negative sign, I ask myself what times what makes 1? Well, that has to be 1 times 1. Now, here's where the middle term comes in, because inner plus outer must equal middle. What do I mean by that? When I say inner, I'm talking about these two terms. So inner, I have 1 cosine theta. Outer is these two terms. When I multiply these, that's going to make 2 cosine theta. And like I said, inner plus outer must equal the middle. And the middle term is 1 cosine theta. Normally I do all of this in my head. I'm just showing it for instructional purposes. We control the signs. So what would the signs have to be on the 1 cosine theta and the 2 cosine theta in order to end up with a positive 1 cosine theta for the middle? Well, I would need a negative 1 cosine theta and a positive 2 cosine theta. In other words, the inner has to be negative, so I'm going to need a negative here. The outer has to be positive, so I'm going to put a plus right here. Always check one last thing before you declare victory. Make sure you are getting the correct sign for the constant. In this case, negative 1 times positive 1 does equal negative 1. So we factored correctly. We can find solutions by setting each factor equal to 0 and solving. If we set 2 cosine theta minus 1 equal to 0, we would add 1 to both sides and then divide by 2. Let's do that mentally, and we will get 1/2. Cosine theta equals 1/2. Similarly, if we set cosine theta plus 1 equal to 0, we're going to end up subtracting 1 from both sides. So we get cosine theta is equal to negative 1. To find the solutions of cosine theta equals 1/2, we start by identifying the reference angle. The cosine of what angle is 1/2? We have memorized that the cosine of pi over 3 is 1/2. So pi over 3 is the reference angle. On the interval from 0 to 2 pi, here are the 4 angles with a reference angle of pi over 3. Since we want cosine to equal positive 1/2, we will stick to the first quadrant and the fourth quadrant, where the x value, and thus the cosine, is positive. In the first quadrant, the angle that has a reference angle of pi over 3 is pi over 3 itself. So that's one solution. Theta equals pi over 3. We can think of 2 pi as 6 pi over 3. So this angle in the fourth quadrant is 5 pi over 3. That's another angle that will cause f of theta to equal 0. What angle will cause cosine theta to equal -1? Cosine is the x value on the unit circle, and right here the x value is 1. But as we rotate to this position, the x coordinate is 0, and when we rotate to here, the x value is now -1. So this is the angle we are looking for, and it is pi. So theta equals pi is a third value that will cause f of theta to equal 0. These are the three values we will use to make the sign chart. On the sign chart, we need a row for each factor. Let's write the critical values that cause f of theta to equal 0 in order from least to greatest across the top. So we start with pi over 3, and then pi, and then 5 pi over 3. Let's not forget to include the domain restrictions, 0 and 2 pi, at the beginning and end of the sign chart. Now we have to decide whether each factor is positive or negative in each interval. It will be helpful if we identify the values that cause each factor to equal 0. So remember that the factor of 2 cosine theta minus 1 led to these two critical values. In other words, 2 cosine theta minus 1 is equal to 0 at pi over 3 and at 5 pi over 3. So these are the only two places where this factor might change signs. So instead of having to test 4 intervals, I really only have to check 3 intervals. The factor of cosine theta plus 1 gave us the value of theta equals pi. So this is the only place where cosine theta plus 1 might change signs. So we really have to only check 2 intervals for this factor, not 4. Let's go back to 2 cosine theta minus 1. We can test this first interval using the value of 0, since 0 is not one of the critical values. Plugging in 0, we would have 2 cosine 0 minus 1. The cosine of 0 is 1. It's the x value right here. So this will be 2 times 1 minus 1, which is positive 1. So this first factor is positive in this interval. In the middle interval, we can use pi as a test value. So we have 2 times cosine pi minus 1. Cosine is the x value, and at pi, the x value is -1. So we have 2 times -1 minus 1. Well, this is -2 minus 1, which is -3. So this factor is negative in this interval. For the last interval, we can use 2 pi as a test value, but we already know that's going to work the same as 0. So we got positive before, we will get positive again. To test whether cosine theta plus 1 is positive or negative between 0 and pi, we can use 0 or we can use pi over 2 among other values. I'm going to mention them both. At 0, the x value, and thus the cosine, is positive 1. That would give positive 1 plus 1, which is positive 2. So this factor is positive in both intervals. If we use pi over 2 for the test value, we know that the x value here, and thus the cosine, is 0. So we'd have 0 plus 1, which is positive 1. Again, confirming that this factor is positive in this interval from 0 to pi. On the interval from pi to 2 pi, we can either use 3 pi over 2 or 2 pi itself as a test value. At 3 pi over 2, the x value and thus the cosine is 0. So we have 0 plus 1, which is positive 1. So this factor is positive on this interval. Similarly, if we used the 2 pi, at 2 pi, the x value is positive 1. So we would have 1 plus 1, which is also positive. What's the overall sign of f of theta in each one of these intervals? In the first interval, we have a positive times a positive, which is a positive. In the next interval, a negative times a positive is a negative. Same with the next interval, a negative times a positive is a negative. And finally, a positive times a positive is a positive. We are looking for the values of theta that will cause f of theta, this expression on the left, to be greater than or equal to 0. Let's identify where the solutions will fall on the number line. We will have solutions between 0 and pi over 3, and between 5 pi over 3 and 2 pi. The endpoints should be included because we are looking for where f of theta is greater than or equal to 0. F of theta was positive at this endpoint, and it is equal to 0 at this endpoint. Either way, we want to include the endpoints, so I'm going to put closed circles here and here. You can record your final answer using interval notation or using inequalities. Either of these formats might appear as an option on a multiple choice question, so be familiar with both. Notice that we indicate that the endpoints are included by using brackets on interval notation and by using less than or equal to signs on these inequalities. Actually, I just realized this answer is incomplete. I have a feeling this is going to be a common mistake, so pay attention. We are looking for the values of theta that will cause f of theta to be greater than or equal to 0. We left out one value where f of theta is equal to 0. See this blue line right here? This was here to remind us that cosine theta plus 1 is equal to 0 at pi. Sure, the other factor is negative at pi, but 0 times a negative number is still 0. So we need to include pi in our solution. In interval notation, we include the single value of pi like this, using braces. We use braces for a list of values or a single value, as opposed to an interval. For the inequality format, right in the middle we add in or theta equals pi. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.